So I've decided that I will make my programs available. They'll be on Patreon, so I'm not giving it for free, just because of the time and effort I put into the programs. It's a lot. So you'll be able to find the link probably in my YouTube like bio or whatnot, and they'll probably be in the description of this video. So the following video will explain to you how you will use GeoMFig. I hope to get the other program tutorials out soon, but for now this will be the only one since this is the main program you'll probably use of mine. But well, I hope that you'll be able to get some out of it and maybe decide to get it yourself. Good morning. So this will be a video of me going over how you use the GeoMFig program. This is for pretty much every geometry figure you could come across, with the exception of triangular prisms. So I will use a few tests as examples, probably four or so, but most of the time they're always on page 3 at the bottom, and my program can get pretty much any geometry problem you come across. So this is what it looks like. You have shapes, of course, and it asks you for which shape. Of course, the triangular prism is a work in progress, so depending on how much, I don't know, popularity this gets, I will finalize it. But for now, since it's uncommon, I will leave it as it is currently, which is just, work in progress state. Uh, so let's look at this hemisphere, right? It's associated with number 5. You could scroll down, but I like just pressing 5 because that instantly loads it up, and we're given the volume of it. So that's 3. So the volume is 187,000. Just like that, and you will run it, and you'll get your answer to be 44.7. That's pretty easy. Then it reloads it after you press enter because, as you can tell, there's always 2. So I decided to, instead of having it automatically exit, it just goes right back to the main menu. Then cylinder, you're given the diameter, but the diameter is just double the radius. So you type radius. And then you're also given the height. It's 0.524 divided by 2. And you're also given 2.48. Scroll down to the volume, 0.535. And that's correct. So that's for that set of problems. Now let me see if I can go on, and looks like sometimes you can use my program for these, sometimes you can't. Uh, and it looks like if I take a second to realize it, I don't think I can use it for this one, but I think I might be able to use it for this one. So cancel. No. Save options. I'm not gonna save it. I just mark up. Oh, I think I might have saved the other one. I didn't mean to do that, but that's all right. So solid cube volume is equal to double the cylinder volume. Well, the solid cube, that's talking about the whole cube area, right? The whole cube volume. And I've gone over these problems before, so you can check it out. But this is just specifically for, the program. And then it's double the cylinder volume. So the cylinder volume is 0.31 cubed, the solid cube volume, divided by 2. So, and we also know what the height is. So, we can use the program for this. Cylinder, and like I said, we're given the height, so it's number 2, and we're also given the volume, number 2. So the height is 0.31. The volume is, as I said, 0.31 cubed divided by 2. Just like that, you get your answer to be the diameter is 0.0247. So, but like I said, I don't think we can use it for number 50. So there's sometimes you still need to know how to do your own geometry, of course. Let me open up a separate test just so I can show some more examples. Okay, this is fun. Uh, so 29 is solved by the program as well, but I have a weird definition for it. So I use a term called midpoint. Well, of course, everyone uses midpoint. That's not uncommon. The uncommon part is all the different names because there's so many different cube problems. So let me explain what each one does. So of course you're going to open up cube, and you got a few options. The first maybe 4 you're familiar with, of course. you have the side length, right, which is just like, for example, this corner right here to B. You know, that's a side length. You've got the volume, which is that side length cubed. You've got the total surface area, which is this side length times that side length, which is, yeah, it's just squared, multiplied by 6. You got the face diagonal, which is from B, for example, all the way down here. That would be a face diagonal. You've got a solid diagonal if it goes from B, that corner B, all the way to the other corner of the cube. Uh, you've got, and then of course we have the midpoints, right? And what I define as a midpoint is the following. So, for example, B to A, I call that a okay, that was terrible, but you can already see the dash. B to A is a solid midpoint distance. So, the solid line, if it goes in all three dimensions, and this is the midpoint towards the corner. So that's why I call it the solid midpoint distance. So that's what we're going to use. And then the face midpoint distance, so if it goes from B all the way to the corner, it just goes. That's the solid. That's the face diagonal. That's the face diagonal. Uh, but then this is the face midpoint distance or whatever. Just like that, and that's half of S. Okay, but yeah, I just wanted to explain that to you. Solid midpoint distance is what we're going to use. And it's no, sorry, my bad. We're asked for that. We're given the side length. Let me go back. I entered the wrong thing. Cube. Sorry, I was a little bit confused. But anyways, we're still gonna have to decipher which one's which here. So as I said, since it's going in all three dimensions, it's solid, and since it doesn't go to the other corner, but the halfway point, it's a solid midpoint. So it's 1.78. And then sphere, super friendly. Number 7. And we're given the total surface area, and it's 0.268. And it gives you the diameter to be 0.292. So you'd write that down. Okay, and then let's check if we can use some for this. It looks like we could use it for 50, if I'm not mistaken. Um, Maybe not actually. There's some things that it can't do, but uh, so the Q volume, which you don't know, minus both the period. Actually, well, you can use it. You can use it. Mm, well, not really. This is an easy problem actually. So, what I mean by that is the volume of a pyramid is very similar to the volume of a cube. It's just divided by 3, right? And you can consider these two to be the same. Actually, you know what? Yeah, I will continue to explain. So yes, the volume of a square pyramid is very similar to the volume of a cube. It's just divided by 3, right? And it has a separate height. So, in essence, this volume of this whole figure is now 2/3 of its initial volume with the cavities, with the pyramid cavities. So, we're going to have to multiply 77.3 by 2 over 3 to undo what was previously done, and that will give us the volume, and then we're going to have to take the cube of it. So, but yeah, I mean, like I said, this doesn't solve every problem. The GeoMFig program doesn't solve every problem, but if you're it helps it go by a lot faster as long as you're not explaining it like I am, you know. That takes you a bit longer. Okay, I'm just gonna only do page 3 now. Okay, and also you can still use the geomfig program for like math. I know math has a problem. Mathematics, I mean, mathematics has a problem every test over a geomfig program. So I mean, it's pretty handy. Okay, let's look at 29 and 30. I'm not gonna zoom in on it. I think y'all can see it from there. So let's go back to geomfig alpha G, and it loads all this junk. Okay, so we're given a sphere, so it's 7, and we're given the sphere's radius, which is 5.26. And you get the total surface area to be 348. Just like that, and then frustum, you're going to press 4. You're given both the radii, and you're given the height. Radius 1 is 0.211 divided by 2. The second radius is 0.646 divided by 2. And then lastly, the height is 0.473. And just like that, you're going to get the volume. So you see, it solves it for you pretty fast, and pretty much freebie problems at that point. Okay, I can move that. All right, we're given a cylinder right there. We're given the radius and the height, 0.0234. Remember, that's the diameter, so you have to divide it by 2, just like how we did with the frustrums a minute ago. Then 0.0375, and then yep, that's it. And then you're given the total surface area. You asked for it, and it's right there. Okay, and then I don't know why I keep on exiting it. I'm so used to the I don't even know. Like I said, like I showed you, it loads it up right after you you get all the answers or whatever. So I gotta try to remember not to do that. Yeah, so it's hemisphere, and you're given the total surface area. So it's 46.9, and you asked for the radius, so it's 2.23. Just like that, and then I only have one more test to go over, but y'all get the gist. Okay, now square pyramid, that's going to be number 8. I'm glad we got one of these. It's very friendly though. Square pyramid, you're given the side length and you're given the height. Like I said, these are very similar to, I guess it would be more rectangle volumes, but since the previous problem that I personally solved for without the program a bit earlier, since it was the height it had the same length of height as it had it in its base, like the base and height were the same, then you could treat it as a cube, you know. Okay, then not 7919, 719. Okay, and then you get your volume after pressing enter, and pretty much all these are self-explanatory. The top angle I'm pretty sure is that right there. If you were to make a, let me check that actually. Uh, so if you were, I'm pretty sure if you were to make a right triangle going towards that base, so it'd be 818 divided by 2, and then you would have tangent, it would be a over h, 719. So, bam, yes, there you are. And then that's my mistake. I just I completely forgot. It's O over H. TOA. All right. And then cone, you have the height and you have the volume. So it's 0.793, and you're also given 0.0771 is the volume. Okay, now it'll figure it out for you. That's the diameter right there. So pretty easy. And now this also gives you the top angle in degrees. Now, which is double. That's B. You see, it's a weird variable. So the angle for a cone is the entire angle. You gotta remember that. While the square pyramid is only half. So if you're ever given the angle or you ask for it, if you're given a half of angle like this, you'll just have to half the answer you get for the top angle in degrees. And if you're asked for the whole angle of this pyramid, then you'll just have to double what you get. So you just gotta remember that. But that's a showcase of my program.